What's up, guys? Let's talk about some operations on random variables. So here's the basic premise. You have a random variable that you've already established what the mean and the standard deviation of that random variable is. What we're doing here in operations on random variables is you're taking your original random variable and you're saying, oh, let's go ahead and add some constant to every single value. So we talk about adding and subtracting a constant. Maybe you take that original random variable and you're like, hey, let's go ahead and change it and multiply everything by 2. So multiplying by some value. Or maybe you have two random variables and you want to combine them, either adding them together or subtracting them is what we talked about down here. So we have a little bit of shortcuts. So instead of taking my original probability model, adding 2 to everything, and then recalculating a new mean and a new standard deviation, or even multiplying by everything and calculating a new mean, instead of recreating that probability model, instead we have these shortcuts so that we don't need to create a new probability model. We could just follow these shortcuts and go ahead and get our new mean and our new standard deviation, okay? So back in my earlier video in this unit, we talked about how to take a probability model and find an expected value and a standard deviation from it. You wouldn't have to do that again. These shortcuts allow you to kind of skip that process if you've already done that. So we'll go into these 3 different types of rules in my examples. In general, what we're going to do with these types of problems, we're going to start with a mean and a standard deviation. And the first thing we're going to do is we need to take it from a mean and a standard deviation to a mean and a variance. If you want to go from a standard deviation to a variance, you're going to take your standard deviation and square it to get to a variance. The next thing we're going to do is we're going to apply these rules. Okay, we're going to apply these rules and get our new mean and our new variance. Okay, so we're going to apply the rules. That's kind of our second phase. And then finally, we're going to take things back down to a mean and a standard deviation. So once you have a variance, if you want to go to a standard deviation, you're just going to square root it to take it back down to a standard deviation. I'll show all these kind of bits and pieces here in 2 examples. So I have 2 random variables for my examples. Random variable x has a mean of 6 and a standard deviation of 4. Random variable y has a mean of 9 and a standard deviation of 5. So I already kind of did our first step here is I took my standard deviations and I changed them to variances. So I took my standard deviation and squared it. The variance of my random variable x is now 16. The variance of random variable y is 25. Okay. So what we want to do is we want to calculate the mean and the standard deviation of the following. I want to know if I would have taken whatever my random variable x is and I subtract off my random variable y, what is my new mean and my new standard deviation? So we're going to skip recreating a probability model and going through those long formulas. We're instead going to use these operations up top to kind of speed the process up. So if I want to find a new mean, we're talking about finding the expected value of x minus y. And what we find is with expected values means you kind of do whatever it tells you to do. If it's going to tell you to take x minus y, well, you're just going to take the expected value of x and subtract off the expected value of y. So the mean of x from up above was 6. The mean of y was 9. So we're doing 6 minus 9. My new mean of x minus y, or the mean of x minus y, I should say, is a little bit better, is negative 3. Easy enough. So we need to find the standard deviation of x minus y. So we're going to start with variance. So I'm right here in my process. I'm at the mean and variance stage. I'm trying to find my new mean and variance, and then we'll finally get to the standard deviation. So the rules state with variances, if you're going to add or subtract 2 random variables, no matter what, you're going to add them together. So even though it says find the variance of x minus y, what we're really going to find is the variance of x plus the variance of y. We're going to take the variance of x plus the variance of y. This, out of all my rules, is probably the most tricky one and the one that students most mess up. So that's why I wanted to highlight it in an example. So we know my variance of x is 16. My variance of y is 25. So 16 plus 25 is 41, okay? So if I'm trying to find the variance of x minus y, we're talking 41. But what we wanted was the standard deviation. I want to know the standard deviation of x minus y. So we're on this last phase here of going from a mean and a variance down to a mean and a standard deviation. So here's my mean, done. To get a standard deviation, you're going to take your variance of 41 and square root it. To go from a standard deviation to a variance, you square it. To go from a variance to a standard deviation, you square root it. So the square root of 41, I already did this kind of off screen, you're going to get 6.40. So that is my new standard deviation. So that's kind of using these operations on random variables to kind of quickly calculate your new mean and standard deviation of different sorts of combinations. One more example for us here. I need to find the mean and the standard deviation of 3x plus 5. So we're going to take the random variable x, multiply it by 3, and add 5. So again, we're going to start with our mean, our expected value, 3x plus 5. Remember with means, you kind of do exactly what it tells you to do. Multiply by 3 and add 5. Means are pretty boring. They're pretty straightforward. You do what it tells you to do. So if you checked out my rules up above, and I talk about them a lot more in class, for means, if I'm telling you to add some constant of 5, take every single value, add 5 to it, well, for the means, you're just going to add 5. When we have a multiplier of 3 for means, well, just take your original mean, EX, and multiply it by 3. Okay, so this is the breakdown of 3x plus 5 following my rules up above. If it's telling you to multiply by 3, you're just going to multiply by 3. If it tells you to add 5, you're going to add 5. Okay, so plug in my information up above. Yes, we have 3. My expected value, my mean of x was 6. And then we're doing plus 5. So we're doing 3 times 6 plus 5. That's 18 plus 5, which is 23. So my new mean, or the mean of 3x plus 5, is 23. Okay, and again, instead of taking my original probability model of x and taking every single piece in that table and multiplying by 3, then adding 5, this is a shortcut that goes much, much quicker. Okay, shortcut goes much, much quicker. Then we got to do the variance here. Remember, the variances, they're going to be the ones we need to pay a lot more attention to. They're the ones that special. Means, pretty straightforward. Variances are where it gets tricky. So they're asking us to add some constant, add 5. Well, when we talk about the kind of rules up above, adding or subtracting some value to every single data point is not going to change your spread, so it's going to have 0 effect on your variance. So that plus 5, it's irrelevant. It's gone. Okay, it's gone. Adding 5 to every single point, yeah, you're going to have space, spread, but adding 5 to every single point just changes the location, but the spread is exactly the same. So plus 5 is gone. When we have a multiplier by 3, if you look up above at our rules, when we have a multiplier, you just need to take that multiplier and square it first, and then multiply it by your actual variance. So we're going to take that 3 out and square it and multiply it by my variance of x. Okay, so we're talking 9, and my variance of x was 16. 9 times 16 is 144. So that's my new variance. To get my standard deviation there, standard deviation represented by sigma of 3x plus 5, we just need to do the square root of our variance, which is 144. Square root of 144 is 12. So if I take the random variable x and want to do 3 times x plus 5, my new mean is 23. My new standard deviation is 12. So that was kind of a quick rundown on how to do operations on random variables. Again, pay very, very close attention to the variances. Pay very, very, very close attention to the variances. If you're going to add or subtract some constant, it has no effect on it. You just keep your variance of x. If you're going to multiply your variance by some number, make sure you square it first and then multiply by your variance. If you're going to add or subtract two random variables with variances, no matter which operation it is, you always add. Okay, I talk much more in depth on these kind of three rules in class time, so this is just a quick rundown on how you apply operations on random variables.